All right, YouTube, we finally got some parts in, a couple tools, and we're ready to start putting together this crankcase on the 288 build that I had started, I don't know, a month ago during the holidays when it was really cold. And actually, things are going to be getting really cold in a day or two, back in the deep freeze. So anyway, it's a good time to keep rebuilding or building this saw. So it's time to put together the crankcase. I think I already showed you putting in the bearings, which went pretty smooth. Now, this here is the crank assembly tool for the 281 and 288. And I was going to use this, but it always bugged me that using these tools don't support the bearing when you're installing the crank, and the chance that you're going to screw up the bearing. SKF has done some research on their bearings showing that 16% of the bearings fail because of brute force application. And even though it's OEM equipment, if I demonstrate this to you on the crank side, here's a brand new OEM crankshaft. If I was going to use this Husqvarna assembly tool, which is pretty simple to use, you put the appropriate end of the sleeve over the crank. You'll then go ahead and slip on the nut here. Once you get this cranked down, it's pretty much just a simple issue of holding the rod up and then cranking on this with get this down tight, and then cranking on the nut here to pull in that crank. Okay, we're not going to do that in this particular case, and I'll show you why. So I guess if you really just, had to get something on and you didn't have a better tool, and these aren't the cheapest crank assembly tools in the world, but there's actually some other alternatives out there, and I came across one designed by Matt Olson, and I do think it's far superior to the OEM crank assembly tool. And here's why. Because you put this sleeve, install it, and start pulling on it, the edge here of the tool is coming up against that surface of the crankcase, and so you've got some pressure against the crankcase. The crankshaft, as it comes through the bearing, is pulling on the bearing, and so in this case, as you're pulling on it, until the inner raceway comes up against this flush portion of the crank, it's actually providing a lot of stress, lateral stress, on the inner raceway here. Same thing with the other side of the case, and in fact it's worse on the other side of the case, because this will not bottom out at some point flush against the inner raceway. So the inner raceway is taking all of that pressure as you're pulling it in. So that had been bugging me for a while, and I just don't know how I stumbled across Matt's YouTube page, but well worth the $200 for a main kit that he sells his crank assembly tool for, because it can be used on a whole lot of other saws that you might be building. And the reason why this is such a nice tool is that it supports that inner race by coming, when you install this on the crank, and you put the sleeve over it here, it will put all of the pressure on that inner race and support that bearing as you're pulling the crankshaft through, essentially stress-free. So there's little chance that you're going to wreck that bearing. And I've wrecked bearings without even knowing it, and with trying the manufacturer recommended tools. A certain proportion of those just take too much stress, and eventually your bearings are going to fail. You just won't get the life out of them. So this is a really easy way to cold install the crankshaft without doing any damage to your bearing. Now, before we do any of that, though, I'm going to check to make sure that we don't have any grime or dirt or particles that might get caught in the bearing here. We've generally got nice clean surfaces. But I do want to liberally coat the crankshaft and the bearings with some two-stroke oil. And at some point here, it'll be pretty important to both make sure things are clean but also lubricated well. I'm not going to go hog wild here. I'm just putting a little bit on both sides. Of the roller sleeves that the bearings are in. Okay, so and we're starting on the clutch side, so again, not a lot, just gonna put a little bit on the shaft there. Might as well go ahead and lube up the bearing and the large end of the rod, bottom end of the rod. So we're just gonna get it started there. All right, get things fairly well lubricated here. All right, good enough. All right, so we're just gonna insert the crank, get it started in the bearing. So this is going to be reverse threaded now, remember. You got to make sure you use the right one. And I had already tested this. And it should go on easy, you don't want to force it. So whatever crank assembly tool you use, you know, it's kind of the same premise really. The only difference on this one is that it's specifically designed to put the support on that inner race. Okay, now there's a hole on this that has to be lined up. I'll try and reposition everything here. Alright, so if you notice, there's a hole right there. And you don't have to get this crazy tight to begin with. But what you're trying to do is line up the slot with the hole on this long carriage bolt. Screw this in all the way and then back off a little bit, because this needs to be able to slide up and down. Because as we tighten things, it's going to slide up that sleeve and pull in the crank. So I'm just initially getting this by hand here. And the beauty about this design too is that it's set up so that you can actually do this by yourself instead of needing a extra hand. So I'll just use one hand to keep the rod up high so that I don't risk it getting bound incorrectly. Carriage bolt supports it, and it's pretty much just an easy affair here of pulling in the crank. Doesn't take much pressure at all. Completely supporting the bearing as the crankshaft gets pulled in through the bearing. You don't need to get this overly tight once you get it. You'll know when it bottoms out. Boom, right there. Okay. Then I'll just reverse it like so. Disassemble the tool. All right, and now we have it assembled in the crank. Everything's looking good. So now, as we get ready to pull it through to assemble the rest of the crankcase, we now need to do some prep work. Grab the other half. Everything looks nice and clean. And I'm going to put a little more oil on this bearing. Okay. So this case is really pretty clean, but it is used. It does have, you know, it's hard to know if there's some little micro depressions along the case gasket facing here. And I'm not going to go hog wild with this, but I am going to use just a little bit of Motoseal, and I mean just a little bit. I'm reliant mainly on the paper gasket, but I'm going to use the Motoseal just to fill in any micro features in the case, to fill those in, so guarantee we're not going to have any leaks along the crankcase. But before I do that, I got 4 case bolts here, and I'm going to give just a little shot of, that's a little too much. Just a little bit of blue Loctite. Get that cleaned up. A little bit before we continue. Didn't expect it to come out quite so quickly like it did. You don't need that much Loctite on these. Okay. Got that set. All right. Now we're going to use a little bit of Motoseal. Most important to put this in the case area. I feel a little better doing just using my fingers. I can feel better. So again, we're not going to go hog wild with this. Just a little bit. Try and keep it fairly consistent across the whole case. We don't so much worry about everything outside of where the crank is, but if we don't have a fairly uniform coating, then it could cause some problems. The other thing this will serve, now the manual says just use grease. That'll help hold the gasket on. But the grease isn't a sealant, and so if you have any issues with the case, then at least the sealant here will help contend with that. If you feel like you put it on a little too thick in a couple places, then I'll go ahead and smooth it out a little bit. I don't necessarily want a lot on the pins. course, the stuff on that, if you put a little too much on the faces outside of the crank area, you'll be able to clean some of that up above and below the case. I'm gonna take a little bit of time here. Just make sure I'm not gonna have too much excess getting into the case. You will have an opportunity to kind of clean that up a little bit after you have it all together. All right. All right. Now we can do the same thing. Okay, we got our pins, got the gasket here, so we do have to put a little bit of sealant now. On this side of the case. So it'll start to tack up a little bit. But you don't have to be in a terrible hurry with this. You may need to move the crank around a little bit. So this sealant is pretty commonly used for this kind of application. Another common sealant would be 3-bond 1184. This is just something that I had available locally. It's heat and oil resistant. So you'll also want to have your case bolts relatively handy, because you'll be able to put those in here pretty soon. I'm just gonna deal with some of the excess here. Where I think maybe it's just a hair too thick, I'm just gonna thin it out a little bit. Got a little bit on the rod there that I don't want. A little bit of slop right there. Okay. I think we're getting pretty close here to ready to rock and roll. All right. I'll close this up before we get gasket maker all over our project. Okay. So this is going to be a similar process on the other side, except I have to get a different size rod here. Because this is a different size. Thread and diameter on the flywheel side. But we've got basically the same process now. So I'm just going to feed the crankshaft through here to get it started. Okay. All right, looking for my actual crankcase bolts. It's kind of an important thing to have handy at this stage. Had it out here earlier. There we go. All right, now we can actually put these in here now. These can help guide. Crankcase together. just gonna get those 4 main case bolts and just barely get them started here. Okay. Yeah, and I can see, maybe I'm gonna take those out because I put a little too much, it looks like, on the one side of the case. Too much sealant, that is, and I just don't like the idea of having any of that or much of it at all on the inside of the crank. So I'm just gonna pop this off. And make sure that I don't have too much of it on the inside of the case. Can't get to it very easily from the top, but I can down here. So here's how we're gonna do that. And I think that'll get her. Okay, so start that again. Okay. So start it like this. Okay, let's do that again. Just gonna start it a little bit. Just barely catch those threads. They're not going anywhere. They're now acting as a guide, and they're not going to interfere with sliding the crank on. All right. Yeah. As we had done before, now it's time to slide this on. I think that was going just fine. Yep. Okay. Now, we're going to put the sleeve back over this, supporting the bearing. I'll get our little support arm here started. Bottom it out, back off a little bit. Make sure she's moving smoothly there. Okay. And we're going to do the same thing now that we did before. The only difference is on this, we're going to have to pay really close attention to make sure that as we get close to those guide pins that everything's matching up all right. So, bring her through nice and easy like. Okay. I'm going to check things here. Getting close to the pins now. Make sure that the pins are lining up. They appear to be guiding onto there nicely. And once the pins are on, pretty much just send it home until you can no longer tighten it. Okay, then we should have it tight. Reverse that. Case should be pretty close to being done here. So now I'm going to finish sending these case bolts home. At first I'm not going to immediately tighten them, just get them down barely snug. Okay, now we're snug. Now I'm going to give it a good wrench and I'm going to work kitty corner here crossways rather than in a clockwise or counterclockwise fashion. That's how it's recommended from the manufacturer to do it. Okay. I'm going to take the dog bolts, and I don't want to put the dogs in yet, and I'm not using Loctite on those. because we have to get the dogs in there, and there's all kinds of times when these bolts need to come out as a saw operator, so those you do not want to use Loctite on those, but it is a good idea to check your torque on those when you're using a saw to make sure that things aren't loosening up. These saws do have quite a bit of vibration to them. And then the last case bolt is the one here in the back. Now, at this point, I am going to do a quick check here on our torque, and it looks like what we need is about 8 Newton meters of torque on those bolts. Oh, we're gonna that's what we've got right about there. Okay. See, that's a 3. What I need is a 4. Okay. So let's just tighten these down to specification. And when you get your saw running, then you're going to want to end up, after several heat cycles, just check your bolts to make sure that they're torqued to spec. And not loosening up on you. Okay. See how that feels in the hand. Yeah, I can't definitely get it that tight. So I was able to get that tighter. I'm not a particularly strong guy. I was able to get that tighter with that little 1/4 inch torque wrench than I was by hand. And you know, you don't have to clean up the gasket material on the outside if you don't want to, but I like doing that. I just don't like extra stuff on my saw. Boy, I wish I had my regular shop handy. It's no fun not being well organized when you're doing this. But that's kind of par for the course to some extent. I always like looking down in the crank here just to see what I've got for any gasket material and whether or not I could take any, especially gasket maker, and see if I can get some out of there. Looking pretty good in there. Okay. I'm going to cut off the gasket here that's sitting above the case. Now it's important to not have much up on that seam right here, because obviously that's where your cylinder gasket needs to go. If you do cut this off and you can't find what you cut off, you gotta go find it in the case, because you do not want to leave that in there. Alright. Just making sure you haven't created a ridge there. That might end up resulting in a leak. Probably wouldn't happen, but you know, extra care and caution is always a good thing. Okay. Well, it probably takes a good 24 hours for this modal seal to really firm up and all that. But chances are, if you put it together quickly, that you're not going to have everything together and ready for a test run before the gasket is cured. You know, and you can decide whether you want to trim off all of the hard gasket. I probably won't. But that is a piece together. And there is no resistance there at all. Boy, that is silky smooth. Yep, that is really nice. Okay, looking pretty good there. See, some of this 2-stroke oil that I put in there is now starting to cover the inside. I'm just going to make sure that I don't have, where I can see some of the modal seal, just make sure I don't have too much down there. I don't want it to be coming loose and causing a problem. looking pretty clean. No real causes for concern here. Nothing left over that's gonna get caught in bearings, or we ought to be pretty good. Okay. All right, now that we got that in place, so I'm just kind of centering the rod here on the lower bearing and just bringing it up against the seam of the case, and she looks awfully close to being centered. So when I've done these in the past before, there's usually been about like 0.06 or 0.07 or so, or 0.6, 0.7 millimeters between the top of the crank here and the side of the case. I usually go with the top here when I measure it as opposed to the bottom. And so let's see, we'll get you lined up here a little bit so you can kind of see that. That slides in really super easy, so there's more than 0.65 of a millimeter there. So let's go up to maybe 0.7. Let's just see what we got. That's a little more resistance there, but I can slide it down pretty easily. Same thing there, a little easier on the right side. I cannot see the difference, but it feels different. These are a little feeler gauge like this really helps you. So let's try 0.75. So it's getting a little tight there, but I can fit it. Not very. Boy, it might be. It's a little tighter on this flywheel side than on the clutch side. I don't think this will make any difference here, but it's about the same. I don't think we're going to have to adjust anything here. I think we got it perfectly centered. If I upsize it now to .8 millimeters, seems to definitely fit a little different on the top end here. So like I said, I prefer to use the top end. That doesn't seem to want to. Yeah, so 0.8. It's too thick. Let's go back to 0.75. Seems now a little bit tighter here on the flywheel side. Not by a whole lot, but a little bit. So we're going to give it a couple wraps here. We'll use that same feeler gauge, 0.75. Still seems to need to come over a little bit. You want to use a soft mallet for that. You don't want to be mushrooming over that end. It might even be a good idea to take the flywheel nut and just put it on there so you don't risk mushrooming it. Okay, it's fitting a little tighter over on this side now. May have dropped that just a little too much over to that side, so we'll just work it a little bit to the other direction, and there, I'm feeling very similar resistance now on either side, so we pretty much have I do think I need to, it's so close to the same that I tap it in on one side and then it goes too far on the other. So up, that's perfect. We've got a perfectly centered crank now. And sometimes if for some reason you're worried about the, if the bearings feel like there's a little resistance there, then that will kind of release that tension of the crank on the bearings. Oh, and I think actually that did work. Wow, is it for silky smooth now. I mean, just beautiful. All right, we're ready to finish putting the crankcase bits on.